This video is going to cover solving absolute value equations as well as inequalities. So let's start by looking at a simple absolute value equation. I have absolute value of x equals 4. What is x? Well, absolute value means magnitude or distance from the origin. When you take the absolute value of a number, you make it positive. It's a distance. So absolute value of x equals 4 means we're trying to find all values, all points that are 4 units away from the origin. And I can visually see on the number line that positive 4 and negative 4 are both 4 units away from 0. So this equation has two solutions. X could equal 4 or negative 4. If I have a more complicated equation, here's another one, absolute value of x minus 3 equals 5. To solve this problem, we can break it up into two equations. Absolute value means distance from the origin is 5. So we can say the x minus 3, the thing inside the absolute value, could equal 5. Or x minus 3 could equal negative 5. So again, if we have absolute value equals a positive number, we can break it into two equations. The thing inside the absolute value could equal positive or the negative number. And then these are two different equations that we can solve. Add 3 to both sides, I get a solution of x equal 8. Second one, add 3 to both sides, I get a solution of x equal negative 2. This particular equation, absolute value of x minus 3 equals 5, is actually asking us to find what points are 5 units away from 3, and that was negative 2 and 8. That corresponds with the work we did earlier. All right, let's do one more. 2 times the absolute value of x minus 3 plus 4 equals 8. Now, to solve this problem, we're going to isolate that absolute value first. We want to get the absolute value by itself, and then we'll break it up into two equations using a positive and a negative. All right, so isolate the absolute value first. That means I have to minus 4 from both sides. That gives me 2 absolute value of x minus 3 equals 4. Divide both sides by 2. So absolute value of x minus 3 equals 2. So we're trying to find all points that are 2 units away from 3. But I'm going to break this up into two equations. The x minus 3 could equal positive 2, or the x minus 3 could equal negative 2. To solve, I add 3 to both sides, and I get a solution of x equal 5, and another one of x equal 1. So again, I have two solutions, 5 and 1. Let's try another one that looks similar. The first step is isolate the absolute value, so that means I have to subtract 4 from both sides. My equation is now absolute value of 3x minus 2 equals negative 3. Now, again, absolute value means distance, technically a distance from the origin. Distances are always positive. Absolute values are always positive or possibly 0. Absolute value is never negative. So because my equation has an absolute value equal a negative, that means there's no solution. I don't have to do any other work here. Anytime you get absolute value equals a negative, your equation has no solution because absolute value is never negative. All right, so moving on to inequalities, let's start by just looking at some linear inequalities. Let's see if we can solve 3x minus 5 less than or equal to x plus 7. So we can solve this just like we would solve an equation. We want to isolate the x, get the x on one side. So I would subtract x from both sides. That gives me 2x minus 5 less than or equal to 7. And then we can add 5 to both sides to get 2x less than or equal to 12. And finally, divide both sides by 2, x less than or equal to 6. So solving an inequality is actually really similar to solving an equation. We'll go through an example that shows one of the differences in a minute. But for now, the steps we use to solve this inequality are the same steps we would use to solve if this were an equation. But our solution is an inequality. Our answer is all x's that are less than or equal to 6, smaller than or equal to 6. On the number line, that's everything that's less than 6, including the number 6 as well. To write this in interval notation, I think the easiest way to do that is to draw it on the number line first, and then in interval notation, you just list the endpoints of your interval. This interval, or shaded in region, starts at the left arrow, which represents negative infinity, and it stops at positive 6. So in interval notation, this is negative infinity to 6. With interval notation, we always use parentheses with infinities. We use parentheses when we have an open interval. That means we're not really including the endpoint. And infinities, we can't really put a point there, so we do the parentheses. If we are including the point in our interval, then we use a square bracket. So negative infinity to 6, and I put the square bracket on the 6 to indicate that 6 is part of that solution or part of that interval. All right, let's take a look at another one. Negative 2x minus 4 bigger than 10. So I'm going to isolate the x, add 4 to both sides. That gives me negative 2x bigger than 14. Now I'm going to divide both sides by negative 2. However, and this is how these linear inequalities are different from linear equations, you have to really pay attention in this division or multiplication step, because if you multiply or divide an inequality by a negative number, the direction of that inequality flips. So notice we had a greater than symbol, but when I divide by negative 2, it changes to a less than symbol. And so my solution is x is less than negative 7. Again, this only happens if you multiply or divide an inequality by a negative number. So anytime you divide or multiply by a negative number, the direction of that inequality flips. So on the number line, my solution is everything that is less than negative 7, but this time we're not including the negative 7. Negative 7 is not part of our answer. So in interval notation, this is the interval from negative infinity to negative 7, but I use parentheses on both parts of the notation. Always use parentheses with infinities. And the negative 7 is not included, so we have to use a parenthesis with that. My next example is considered a three-part inequality. Negative 2 less than or equal to 5x minus 3 less than 10. A three-part inequality is technically two different inequalities that we're kind of combining into one statement so that we can solve it a little bit faster. Technically, this problem is saying 5x minus 3 is less than 10, and 5x minus 3 is bigger than or equal to negative 2. So both of those statements are true. I have an and there. And so I can combine that into one three-part inequality. Then when I do the solving, I'm still isolating the x, but now I just do the same thing to all three parts. So I want x by itself, so I add 3 to all three parts. That gives me 1 less than or equal to 5x less than 13. And then finally divide all three parts by 5, and there's my final answer. 1/5 less than or equal to x less than 13/5. This is telling me that x is bigger than 1/5, but smaller than 13/5. X lies between those two values. In other words, x is less than 13/5 and x is bigger than or equal to 1/5. So on the number line, my solution is everything that is bigger than 1/5 but smaller than, and 13/5 is 2 3/5, so I just kind of estimated where that was. So everything bigger than 1/5 and smaller than 2 3/5. Because I have the bigger than or equal to symbol with the 1/5, I use the square bracket. I have the less than symbol, there's no equal sign there, with the 13/5, so I use the parentheses there. So this is telling me that 1/5 is part of my answer, 13/5 isn't, and everything between those numbers is also part of my answer. All right, so now I think we're ready to dive into the absolute value inequalities. So let's start with a simple one. If absolute value of x is bigger than 4, what does that mean? What is that telling us? That is telling us the distance to the origin is bigger than 4. So we are interested in all points that are more than 4 units away from the origin. So we're talking about the ends of the number line, places that are further than 4 units away. So that would be everything that is bigger than 4, but also everything that is smaller than -4. In interval notation, we have to write this as 2 separate intervals because we are talking about 2 different places on the number line. So this would be everything from -infinity to -4, and then I'm going to do a U. It stands for union, so it just means all of these points or everything from 4 to infinity. And notice I did the parentheses because we don't have that or equal to symbol. So here's my interval notation. We could also write our solution as x is less than -4 or x is bigger than 4. So what if we change this to a less than symbol? What are the points that have a distance to the origin that is less than 4? Well, now we're talking about the middle of the number line. All points that are less than 4 units from the middle would be everything from -4 to +4. In interval notation, we can write that as one interval because we're talking about one chunk on the number line, everything from -4 to 4. Because we're talking about one chunk on the number line, we can also write this as one 3-part inequality, -4 less than x less than 4. Or we could say it's all points that are bigger than -4 and less than +4. What if we have an absolute value of x is bigger than -4? This is saying distance is bigger than -4. Well, distance is always positive. Your distance will always be bigger than a negative number. So this is every single point on the number line. Every single point on the number line has a distance that's bigger than a negative number. Since this is always true, my answer is -infinity to +infinity, or all real numbers. This is going to happen anytime you have an absolute value bigger than a negative number. If you have absolute value less than a negative number, this is now saying distance is less than -4. When is that true? Well, that's never true. And so in this situation, our answer is no solution. Anytime you have an absolute value less than a negative, that's never possible. The answer is no solution. If we want to solve an absolute value inequality in general, the first step is to isolate the absolute value. So the example I have is absolute value of x minus 3 plus 5 less than or equal to 10. So I'm going to subtract 5 from both sides, and now I've got absolute value of x minus 3 less than or equal to 5. The next step depends on whether you have a less than or greater than symbol, and whether you're dealing with a positive or negative number. In this case, we have absolute value less than a positive number. Anytime you have absolute value of something less than a positive number, you are talking about the middle part of the number line. We're saying the distance is smaller than something, so we've got a middle chunk of the number line, and we can always convert that absolute value inequality into one 3-part inequality. That's because we're talking about one chunk of the number line. We can write it as one inequality. And the way to do that, in general, if you have absolute value of something less than a positive number, that means the thing inside the absolute value is bigger than -n and smaller than positive n. So you can say that thing inside the absolute value is between negative n and positive n. And so I can take my absolute value inequality and rewrite it as negative 5 is less than or equal to x minus 3 is less than or equal to 5. I can solve this by isolating the x by adding 3 to all three parts. That gives me negative 2 less than or equal to x less than or equal to 8. So we are talking about all points between negative 2 and 8. And because I have those or equal to symbols, I can use the square brackets. All right, my next example, absolute value of x plus 3 minus 2 is bigger than or equal to 8. So the first step is to isolate that absolute value. Add 2 to both sides. Now I've got absolute value of x plus 3 is bigger than or equal to 10. This time, we have absolute value is bigger than a positive number. We're saying the distance is larger than something, so we're talking about the ends of the number line. We're going to have to write this as two separate inequalities, one for each end. The way to do this is if we have absolute value of something is bigger than a positive number, that means the thing inside of the absolute value is bigger than that number or smaller than the negative value. So in this case, I've got absolute value of x plus 3 is bigger than or equal to 10. So that means x plus 3 is bigger than or equal to 10, or x plus 3 is less than or equal to negative 10. Notice the inequality flips with the negative. Then to solve, I subtract 3 from both sides. That gives me x is bigger than or equal to 7, or x is less than or equal to negative 13. In interval notation, less than or equal to negative 13 is negative infinity to negative 13. And I'll do that u to just represent or x is bigger than or equal to 7, so everything from 7 to infinity. So notice our answer is the two ends of the number line. So anytime you have absolute value bigger than a positive number, you're going to break it up into two separate inequalities, and your answer is going to be the two ends of the number line. All right, that was my last example. The other two cases, just to remind you, if you have absolute value bigger than a negative, you don't have to do any work. Your answer is all real numbers. If you have absolute value less than a negative, your answer is no solution. That one's not possible. All right, that was my last example. As always, please let me know if anything is unclear.